recording. Cool. And that, so you can click around in the thing. All right. So, Unreal's input stack. Hi, I'm Nick. My name is Nicholas Hellish. Introduction. This is just a brain dump to explain like the input framework and stuff. So that way, like, you're not confused about where it comes from past the input component. And like you'll be able to know where to plug in your input hook-ins for like when you're dealing with UI and you want to get the input before even the UI does. So that way, if you want to do context switching and all that fun stuff. And just kind of giving a general overview of like when the player presses the button to when it reaches like your pawn or whatever. As a background, some of the stuff I worked with was mobile touch inputs, gamepad inputs, keyboard and mouse, some VR stuff. I have not messed with XR specifically and like gestures or the enhanced input plugin. So yeah. So input context, there's generally like three input contexts, you know, for if you want to include gyroscope, but there's basically keyboard and mouse for, you know, PC, Mac, Linux. Xbox allows you to plug in the keyboard and mouse. Some touchscreen devices support keyboard and mouse, you know, at least like a keyboard, you know, that kind of stuff. Gamepad context is for like, you know, and that includes VR controllers. It includes like Xbox, PlayStation, Switch, and of course PC, because you can plug in a gamepad into whatever. And as well as iPhones, I forgot to mention that. You can connect it with your phones, Android, iPhone, etc. And touch is pretty obvious. It's for like touch screens, phones, tablets, that kind of fun stuff. The Switch is one of those because it does have touch input, as well as gyroscope stuff, which is more commonly used with phones and Switch and that sort of stuff. You can use it with the PlayStation controller, I know that. It's just kind of like not commonly used unless you're doing PlayStation exclusive stuff. They tend to want to use the gyroscope for those games as a showcase. As a bit of an important note, when you're building out stuff for gyroscopes and like for a specific platform, it's good to put it into a plugin. That's what I was saying, like i.e. PlayStation input plugin, Android input plugin, iOS, because when you switch to those platforms, then it basically encapsulates all of your input related gyroscope stuff into that plugin and makes it pretty easy to take in and out of your project and reuse it if needed. So the general flow of Unreal Engine's input. So each stage directly calls to the next one. So from the very beginning, it starts at the engine heartbeat tick. So Unreal Engine's heartbeat tick notifies your platform SDKs like tick update every frame. And this is like the platform agnostic API that is pretty much a plugin or its own module. I can't say specifically because of non-disclosure agreements regarding Xbox, PlayStation, Switch, those sort of things, but it's kind of the same deal across the board of like, there's a module for code specifically for that platform. So there's a module for Xbox that you would get from Xbox as an SDK or whatever. You would get one from PlayStation, Switch, etc. There's some already in the engine for Windows, Android, iOS, etc. So what happens is the engine will tick, then it tells the platform API to tick, and this happens every frame. So this is pulled every frame for inputs and anything else that's regarding, you know, that specific platform. And then the next step of it goes to the Slate application. So you may be wondering, why the Slate application? Well, remember how your inputs will get consumed by UI? This is where it goes to. The platform agnostic API will basically create your Slate application in there and point to it and say, all right, now that I've got like an input or something, I'm going to tell the Slate application input was pressed, released. I think it was held for some of them, or it's in the Slate application. I need to double check, but it's the same process of it's going to resend the input of pressed if it's being held. And then from there, this all basically gets routed throughout the Slate application, where it sends it first to input processors. And you may be wondering what input processors are. They are generic C++ classes. They can be dynamically added and removed from a list of input preprocessors. That's what it's called, is input preprocessors within the Slate application. So it's a literal array of input processors inside the Slate application that it tells it, hey, I got an input or I released an input. Here's what just happened, and it tells the input processor. And the input processor can even consume that input. So your UI wouldn't even get it and it wouldn't pass through the rest of the game. Like you can cut off input right at the input processor and that's it. But it can also travel through the rest of it if you just let it pass through and not consume it. It's also recommended to make one for your own project because it gives you full control of your inputs before anything else in the engine does, really. And if you need an example of how they're kind of constructed out, Epic's already made an example in the engine called the analog cursor. This will also get input if you're using the different input modes like UI only or game only and stuff like that, because it happens before those even kind of like affect anything. And we'll go into those momentarily. But I just want to note that input processors are optional, and you can basically add and remove them at runtime at will. It makes it very easy to just kind of plug in different input processors for specific things, or just have one run for the game for your player, So then the next step after it passes through the input processor stuff, if it has any to like run this input to, is any like focus Slate UI elements or Slate widgets. As a reminder, UMG is a wrapper for Slate. So whenever you're talking about UMG, you're also talking about Slate just by default. So any like focused Slate widgets will receive those inputs, and each widget is usually has some code in there already in the engine for how it handles it, like a button when it gets the button clicked input from the Slate application, it tells it, hey, I'm pressing it, so then the button actually will, count that it's clicked or pressed or whatever. So yeah. And then it usually will also route those into the UMG widgets. So you can override inside of UMG for some of, or not override, but branch off of what's supposed to happen. So like for a button, you can also have this was pressed, so call whatever the default button functionality is and also do whatever you're intending to. But that's more in like the widget hierarchy code of your project. So after the UI elements have received the input and none of them have consumed it, and as a heads up, consuming input is basically it takes the input and it doesn't allow it to continue past its stage of input flow. So if the input processor consumed it, then it wouldn't go to the next step. If Focus Slate widget didn't consume it, then it wouldn't go to the next step of Game Viewport Client. Speaking of Game Viewport Client, the Game Viewport Client is also a widget within itself. So when you are sending inputs to a Focus Slate widget, you can also send it just directly to the Game Viewport Client as, the focused event. And basically what happens with the Game Viewport Client is when you're looking through the code, it's going to seem a little confusing for figuring out where the input is routed to in the Game Viewport Client, but at its core level, if the Slate application sent it to the Slate elements and it didn't get consumed, then it gets routed to the final, it gets routed down to the widget, Viewport widget, which is the Slate widget, and that is routed into the actual Game Viewport Client UObject. So there's an actual Game Viewport widget and a Game Viewport Client object. That's the UObject one that you would override in your project, which handles propagating the input to the rest of your game engine, or not just to the rest of the game engine, but to your project and to your game, and connecting with the game code. This is the point where, depending on which input mode you're using, like input game or input game and UI, or input game or UI only. Sorry, it's a lot of repeating the same name. They will allow the pawns to receive input or not receive input and so forth. So if it's allowing the pawns to receive input, then it will route it to the player controller. We will also go into a little bit more specifics regarding that momentarily. Once the Game Viewport receives the input and it passes through all those checks regarding the input mode, that means it's usable for game code. And then it tells the player controller to add it to its input stack, inside of a function called process player input, and this is called from the player controller's tick. And from there it goes to the player input, and then from there it goes to the input component, and then from there, if you've followed any Unreal Engine documentation on just binding inputs, that's the point where your pawn is getting those inputs and able to do fun gameplay things. So next page. So the Slate application. This is the, as I said earlier, this is the actual introduction into the game layer that your project can hook into. It holds the input processors, tracks all UMG Slate UI elements just kind of through its programming pattern, so it's not directly tracking them. It's tracking them through widget paths, and that goes into more of a UI explanation. Like I can go on and on about that, but this is regarding the input stack. But it basically holds also all of the game viewport clients that are on screen and split screen, or at least tracks them, so that way it can send those inputs to them. So that way when, you know, player 2 presses a button, it doesn't send it to player 1, it sends it to player 2's game viewport client. So the input processor, then the UMG elements, and then the game viewport client that cause the input. This is to account for split screen, so that was just me doing a run through of it, of the steps: input processor, then UI, then game viewport client. So the game viewport client, that's the real game layer of input that you can hook into for projects. This propagates input to the rest of your game in case you are playing like same screen co-op as well. It's modified through the input mode types from the player controller, and input mode is not input context. Input context is basically the gamepad or touchscreen or keyboard and mouse. And this is just an explanation of what it specifically does with those input modes. So whenever you actually call like input mode game only or UI only or game and UI, it literally is just telling grabbing the game viewport client and changing values on it. So in UI only, it literally tells the game viewport client to ignore inputs. Like it turns on a flag saying ignore inputs, so that any inputs that the game viewport client receives are just discarded and consumed. So nothing really happens when you press a button, kind of thing. Unless you're focusing on a UI element, because that's happening before the game viewport client receives those inputs. So the input stack's starting to make sense, hopefully. And then when you have it as game only, that means it allows the game viewport client to receive those inputs, and it locks the mouse so it cannot click around in the viewport. So it kind of like keeps it centered in the viewport so that way it can't move around. Whereas game and UI will release the mouse so you can actually click around in the viewport or move it around the viewport if your mouse lock mode says, like, you know, unlocked or so forth, or locked within the capture. And that goes into another thing about capturing, is pretty much like when you are holding input from the mouse. So basically, like, you're clicking into a button and then you're releasing, it kind of has capture over that button. But the four main mouse lock modes are do not lock, lock on capture, lock always, and lock in full screen. So do not lock basically keeps it within the doesn't keep it. It allows you to just move out of the viewport into like another window or something. So if you had a second monitor, you can drag the mouse over. Lock on capture would basically, when you're clicking, it locks the mouse so it can't move. And then lock always basically keeps the mouse within the viewport so you can't move outside the window. And then lock in viewport is if you're in viewport, or not in viewport, if you're in full screen. Lock in full screen. That's only if you're in actual like full screen mode kind of thing. So split screen and the game layer manager. Let me scroll down to my notes. All right, sorry. So split screen works where it has a game layer manager. And just to help everyone, that's where the location of the game layer manager is in the engine's sGameLayerManager.h.cpp. And inside of there is an interface where it's an iGameLayer Manager. It's an interface that manages, you know, the viewport widgets that are used for split screen. So the Game Layer Manager is used for co-op and split screen usually on the same machine, where it's managing the different viewports that you have. So if anyone's played A Way Out or oh, the recent one, I apologize, I forget their name. The name of it. I just played it too. If anyone wants to chime in. Yeah, It Takes Two. Thank you. It Takes Two also does it, where it's basically they're probably using the game layer manager to change the size of the viewports, because that also is what the game layer manager can do and manage. It does require source code changes to actually do those sort of things. It's something that I've wanted to make a pull request to Epic about, just at least making it exposed to the project settings, so that way we can override it and then put in our own stuff, because that would make life a lot easier. But yeah, so the game layer manager, it manages the viewport Slate widgets, because remember how I said the viewport is really comprised of a Slate widget and a UObject widget, or not widget, but UObject, which is the U game viewport client. Basically, the game layer manager manages the Slate part of it, where it's showing the actual widget viewport for which player that's using that Slate widget and how to shape it and everything. So it's kind of like keeping track of, okay, player 1 is this Slate widget, player 2 is this other Slate widget, player 3 is this other Slate widget, and they're shaped like this. So the top two are going to be, kind of split down the middle, but also like the top layer of the screen, while the third one is going to be stretched across the bottom with no other viewport in the middle, because it's just covering the bottom half. It's instanced by the game engine on initialization inside of the GameEngine.cpp file and in the playlevel.cpp file. It's hard-coded, which it goes back into what I was saying about making that pull request so we can actually change it. So for you to be able to change it right now would require a engine modification. When you're displaying a widget to the screen, you have two options really, which is add to viewport, and then there's add to player screen. And adding it to the entire game viewport covers both or all players' viewports with that one widget, because there's actually another container that holds all of the widgets together, or all of the viewports together. So that way it would add it to that as a layer. So the game layer manager is behind that overlay viewport, essentially. And this is just for like same screen, like having to split up the different game viewport clients kind of thing. And then there's add to player screen, which you can basically add it to a specific viewport. So the game layer manager, as I said, it's an interface. The viewport layout is set in the game viewport client, but it's actually calculated by the game layer manager. So this is regarding what I was saying earlier about the two viewports that are side to side on the top half, while the third one is in the bottom half. This is pretty much what the game view layer manager calculates and then sends to the game viewport client. But the game viewport client is right now hard coded to actually grab it from that as element 0, 1, 2, 3, 4, etc. based on how many players and everything. I'm just looking at my notes. So when a change to DPI scaling happens, it also changes each viewport widget in this case, where the DPI scaling of the project or of the game is going to be affecting all the viewport widgets through the game layer manager, essentially. So if you ever needed to override how it affects the actual game's viewport, that would also be the point of contact to do so. So now the player controller and the player input. It's explicitly told by the game viewport client to add an input to its input stack. Yeah, so this is the part where I was saying where it's basically the player controller is calling tick every frame as usual, and then it calls, in that tick, it's calling process player input. And from there, it actually has a literal like array of keys and inputs that are being sent in from the game viewport client. So the game viewport client is grabbing that array and just adding to it. So that way, when the player controller ticks, it sees this new change in the array and then processes those inputs. So then after that, it sends it to the player input object. This is inside of the player controller. It manages and receives those inputs, and sends it to any pawns or input components that are on its input stack. So whenever you're doing like enable input, disable input on an actor, this is usually where the player's input object is going to kind of hook into that and call it directly. This is also before it actually like sends this information to those pawns or input components. This is also where it figures out, is it an input action, is it an input access, and so forth. It doesn't actually set up the settings, it pulls that from the input settings, but this is where it actually just kind of figures it out. So it's like this object manages figuring out if it's lined up with the settings that it got, and then the input settings is the one that just sends the configurations to the player input. And then so forth, the input component is now receiving the inputs after the player input. Sorry, it's a lot of input. But so player input then sends it to the input component. This is the common, hooking into it, so that way, your player can jump and so forth. At this point, it has gone through all the checks of like, can the UI override it? Can the UI consume it? Is the input processor consuming it, and so forth. So this is like the very tail end of where you're receiving input in the engine, as well as like any other objects that are listening for it. So from this is kind of like just on the side. I have looked at the enhanced input plugin only lightly. I haven't dug into it. I do know that they are using the input component UObjects, and they're also using it in the common UI plugin. This is probably so they can hook into that if someone wants to use game-only inputs, input mode, so that way they can just, bind it to the input component, and then there you go, you're still receiving inputs normally. But this would be the case where if you don't want to have to deal with the tail end of inputs and you want to receive it earlier, then you wouldn't be using the input component at all. I personally use it for just players and just for the pawns moving around and that sort of thing. Anything else outside of that, I will use it in the player controller, or the input processor, or my own like input manager sort of thing, which is really just using an input processor, but it's just different ways of doing things. So the input processors, back to this one. So as I said earlier, they're generic C++ objects that will work with Unreal's shared pointer framework. And they can be really lightweight because they're only like a handful of functions. And as I said earlier, they have an example, which is the analog cursor, where it's literally you being able to move the cursor around with your thumbstick on your controller, like you were playing Destiny or something. They receive input, as I said earlier, directly from the Slate application before Slate and UMG receive it. So you're getting it right in the middle between those two, and you can even stop it from getting to Slate or UMG, even if you're only using UI input mode. And it can be set up for listening for any input on the machine or tied to a specific player, because you can instance multiple of them. You can instance multiples, you can, as long as you properly have them, reference counted and managed, memory managed, using the shared pointers, like you can just keep making them and add them to the list and so forth. That's kind of on you at that point and how you've structured your code. I try to tie it to one input manager per player as I'm making them. So that way I just give it an index and then it's kind of mapped to that, and it won't be able to function if the player that sent this key is not, tied with the player for this input processor. So as I said earlier, there's an example in the engine called analog cursor. So input events and UI navigation types. This is just kind of a quick overview of like the different actual input events that are used throughout the engine. So they all kind of inherit from f input event. This basically just has a tracking of the user index and if it's a repeat input and those sort of things. So let me get my notes of that, because it's a lot more detailed in that sort of sense when you're actually looking through it. But basically, it maps this input to a specific player. So if you have player 0 or player 1, player 2, player 3, so forth, the user index is that one. So there is going to be a player 0. And and then player 1 is going to be index 1, so forth. Or it's really going to be player 2, but index 1, so forth, arrays. So these are the general types of, these are the child versions of input events. They all inherit from it. There's key event, which is any general button input like gamepad buttons, keyboard and mouse, etc. Then there's analog input events. These ones are like gamepad thumbsticks where you have, something that's always happening where it can be 0 to 1 to -1 and so forth. And then you have character events. I have not used them personally, but they're pretty much Unicode 16 character codes. Literally just that. I'm pretty sure they're used for specific widgets and like on key char functionality kind of stuff regarding like, typing in code, text and everything. Then you have pointer events, which are basically the mouse and touch inputs. It even has a thing of, is this a touch input inside of there? So you can just check that. F motion events are basically gyroscope events. They include like acceleration, gravity, tilt, rotation rate, etc. And then you have navigation events. So navigation events are specific to Slate and UMG navigation when you're focusing a button and you want to focus like another button. That's what they basically send across is like navigation events, where they'll have like a genesis and a navigation type if it's going left, up, down, right, etc. And navigation genesises are pretty interesting. That was a little tongue twister. They are basically just us being able to tell what was the cause of this UI navigation. So these are the three main ones, which are basically keyboard, controller, and user. Keyboard and controller are pretty obvious. Keyboard's, keyboard input, gamepad is controller. And then user is actually caused by like user events such as game code or a widget specific functionality, like it's capturing it because you're clicking and dragging inside that widget, like the scroll box or something. So those are typically like those are the three navigation genesis types that are used for focus navigation. So some closing notes. I hope this has been helpful before I continue. So the gamepad counting. So you know how you have two gamepads connected into a machine? At the moment, it's not really exposed or implementable without source code changes, at least from what I've seen. And that's, in default Unreal right now if you were to get the launcher version. And the main reason is because some of their code is literally set up to only check one gamepad, and if any gamepads are checked, even though it does allow you to see the other gamepads, it just doesn't keep track of who's who. There's even some code in the Slate application that is set up, but it's not fully implemented, which is kind of frustrating. So if you wanted to know how many gamepads are connected to a machine, that you got to make source code changes. That's, again, I'm not going to talk about Xbox, PlayStation, Switch SDK stuff, mainly because of NDA. Whether or not they do, I can't say legally. Just, so knowing the gamepad type is also not easy, or at least trivial, because it does require source code changes in the sense, or not source code changes, but just building out your own module and then hooking into it. That's also another method of doing the gamepad counting and gamepad type, but it's like you already have the platform SDK ticking, so it's like, why not, override and so forth, or at least implement from there. So like, let's say if I'm using an Xbox controller and I want to switch to a PlayStation controller on the device, there's really not any good way of knowing which type you're using at the moment. It just knows you're using a gamepad. It can tell you the information if you look at the source code when it's running, but it will not have any hooks for you to actually use it in game code unless you specifically get access to that platform API. This is just me helping out with anyone trying to find out an example of using the analog cursor for a project. Nick Darnell, who created Slate, he and UMG, he also made a project where it was a gamepad cursor, and then a community member named Rama made a plugin project for it called UE4 Gamepad UMG. And that's pretty much his GitHub handle is EverNewJoy, so I just wanted to include that name there. and I forked from it so that way it could be updated because it hasn't been updated in a while. So if you want like a recent that would actually be usable version of it, you can use my fork. Or if you just want to look at the source code, you can go on GitHub and look at Rama's version of it. And another thing is also using the raw input plugin for supporting other devices. It's a totally valid way of doing things as well regarding like, you know, different kinds of devices like a wheel or something like that, or different gamepad types, or the Nimbus controller and stuff like that. But yeah. Also, best part, we have source code access. You can look at all this code and have it run, and you can test it and play with it. It's all available, which is the best part about working in Unreal, in my opinion, is it's all available, you know, at least the source code access that you need to do what you need to. Don't be afraid to put a breakpoint inside the engine and then see where it goes. So, thanks for listening. If anyone has any questions, I'm just gonna hang around for a little bit for any questions, Q&A, or any discussion that happens. This is still being recorded, so in case if anyone wants to hear the answers to those questions, you know. So
Cool. Thank you very much for sharing. I don't have any questions, but I can already tell this video will be very nice to reference every time I have to look at Slate input stock stuff. So thanks for doing the talk.
yeah, happy to help.
As someone who has done a lot of input diving myself, an important gotcha that when you get tripped up by this, you can go, oh, that's what's happening. If you're using a preprocessor and it eats an event before it goes down the stack, like let's say you're using, literally, I think we are using a version of that virtual cursor plugin. If you had an ongoing input in some system before, it will not receive the on-key up event if the input that triggered it, the input down that triggered it, popped you into that mode where that preprocessor is now active.
Oh, interesting. I haven't run into that myself.
It's actually, so with enhanced input, which I know you haven't dealt with a bunch. So enhanced input is doing a lot of state tracking for, hey, when is this event started? When is this event ended? If you're doing something in the preprocessor that grabs, say, the A button on a controller for virtual cursor, the A button up event will never naturally get through into the enhanced input system, so it'll consider that input event to be, continually
Oh,
held. So if you find yourself in that kind of situation, that's where the gotcha is.
I see. Interesting. Oh yeah, that also reminds me. I guess I should probably let people know if you're trying to tie like an input processor to a player specific, best case is use the local player subsystem. It gets instance and just kind of stays alive between levels, so you don't have to destroy it every level. And it just basically will handle cleanup as well. So if you tie it to that, that's pretty helpful. But yeah, no, that's very informative in terms of having to track like when it's released versus pressed and everything, and dealing with those input conflicts, because that can happen.
Yeah, I find it very useful just to think of like where in the chain is the input I'm working with live, and things above it in the chain will eat events.
Oh, for sure. There's also a there's been a few cases where I've dealt with that on the UMG slide or UMG side of it, rather than, I guess in your case, with the analog cursor, because I haven't used that for any of my projects. But it's a lot of like, you just kind of have to make sure that if something is capturing the input or anything like that, that it needs to also release it and have an exit path. All right. Any other questions or?
Yeah, I had a quick question.
Yep.
So I was curious if you've looked into common UI at all, because I know that's been a bit back and forth in the community, and I know that it modifies how input is handled in the UI. So I was just curious if you had any thoughts on it.
Yeah, no, I think it's super helpful, and it's, from what I've seen, the way that the common UI is set up, it's even the name of it is common UI. It's meant to handle a lot of common cases regarding like how games make UI. and how we structure like not only our inputs with it regarding UI, but just like UI in general. It basically, from what I've seen, just uses the input component, so like the tail end of input, but it's that thing of you don't actually have to directly use it if you want, which is pretty nice. You can have all of the nice other stuff regarding common UI and just kind of exclude that or include it. There's definitely good cases of like if you're dealing with an RTS that needs to have game and UI, the input component would be very useful for that. Like, you know, being able to click in your UI elements and then click back into the level without having to deal with like, you know, switching game modes or anything like that, or dealing with like weird nonsense regarding it. Oh yeah, that also reminds me. So the the input modes themselves, since all they do is just modify public values in the game viewport client, you can directly modify those values yourself. So you don't actually need to like go and use the input modes if you want to. They're just kind of meant for shorthand use kind of thing. I use them for just quickly switching to this input mode because I know it's going to handle everything I need. But if you want to directly like change those values, you can do so. And as I said earlier, the source code is available, so you can always look at the input mode itself and see what it's changing, and then just go, well, I want to change one thing. I'll just do my own version. But yeah, no, the input component in the common UI is very useful. It's a thing of you need to evaluate it for your project more than trying to use it for every kind of case, because as we all know, we make a game, like there's not everything has to be used inside the engine. It's more of, do you need this part or do you need this part? I hope that answers the question.
Yeah, it definitely does. Thanks.
Yeah.
I have a question.
Yep.
So, like I heard you saying like stuff about the input stack. So like player controller gets the input before pawns, right?
Yes. Here, let me go back to that input flow one, so that way it makes it easy to see where we're at. All right.
Yeah. So just like to get it, like if I get it right, so actors get input after pawns, or they get input like before player controllers?
The actors can get input directly from the player controller, and the way they do it is through the input component. So like the one right before gameplay, because every actor has an input component object on it. They're basically just objects that are meant to be used, so you can throw it onto anything and then receive inputs from the player controller. So you just tie it to that, which is pretty nice. If you want to, I'd suggest. Oh, yeah.
Yeah. So like I was saying, like actors get input after player controllers before pawns.
Actors do and do
like
not. It depends. It kind of depends on like how the array is set up. So like, I'm pretty sure the pawns will receive it first, usually, if you're adding the actor after they've like hooked into it, because that's typically how it is like the pawns are hooking into it when you do the setup input component function. That's basically hooking it into that player controller's player input list of, you know, actors to send these inputs to and input actions. But it's built on an array of, you know, iterating at a certain point. It just has to iterate through and say, all right, we press this, we press this, we press this kind of thing.
I see.
Yeah.
Nice.
So
and just like yeah, like I was thinking like, and there's like level scripts. You probably didn't mention this. Do they get input? Like I've seen this somewhere that they get input like after player controllers and before pawns, right?
Yeah, that's probably
Okay.
because some of them are in a different slot in the order of the array and everything. So it may be the case where you might have to have an input router, so that way all the inputs go through this guy, and then it sends it to, you know, the animations and then the pawn in a specific order that you specify in the code, rather than like leaving it up to the player controller. Plus, it just kind of cleans up the code architecture, because then it's like everything's first going, all the actual input is directly going to this one source, and then from that source we control like which one goes first in terms of what to do with that input, if that makes sense.
Yeah, makes sense. Thank you.
So if you're just using a bunch of input components, there's a function in player controller called build input stack, that controls what order input components will be pulled in.
Oh yeah, there you go.
By default, it's when you add an input component. So that means anything that's not the actual controller or pawn itself that you've called add to input or add to stack. I forget what the actual function name is.
I think it's
those will
enable
be
input.
in. Those will be the last added first order, and then it will do the player controller's input component itself, and then I believe it's the pawn's input component after that. That's the default ordering in player controller build input stack. There's also like the level itself has a in input component so that like level blueprint can receive key events, and I forget where that is in the in the scheme of things, but that's the function you want to go check out if you're more interested in precise orderings.
So lattice enabled is like process first.
The newest one that has been enabled gets the first crack at an input for input components.
Yeah, makes sense.
I just realized I didn't
Thank
have
you.
the stream chat open. Yep, sorry. Yep. Open that. Okay. Any other questions, or? Because I didn't know about the input stack build as well, or the function for building the stack, so that's super helpful to me. I don't use the input component much, other than just the player, and I just usually disable input when I'm switching to like anything regarding UI.
Can we get the PowerPoint, like this PowerPoint thing?
Yeah, sure. I'll share a copy of it in the Discord channel and also in the description of the YouTube video, so that way anyone can just jump in and download it from my Google Drive.
Oh, thank you.
Okay. Well, I'm gonna assume that means that's the end of the questions. If you have any other questions later on, you can always ask me in the Discord. I do ask that you do it in the public one, so that way everyone else can see the answers and questions and responses kind of thing. Yeah, thanks for coming to my talk. I hope it was very helpful.
Yeah.
I will post this stuff momentarily.